It is the year 2912. The spaceship Titanic was an interstellar passenger liner launched a month ago. The vessel set out on its maiden voyage, transporting immigrants from our solar system to 3 newly habitable exoplanets orbiting nearby stars, while rounding Alpha Centauri en route to its first destination, the torrid 55 Cancri E. The unwary spaceship Titanic collided with a space-time anomaly hidden within a dust cloud. Sadly, it met a similar fate as its namesake from 1,000 years before. Though the ship stayed intact, almost half of the passengers were transported to an alternate dimension. To help rescue crews and retrieve the lost passengers, you are tasked to predict which passengers were transported by the anomaly, using records recovered from the spaceship's damaged computer system. Help save them and change history.
Alright, and that's an epic introductory background into today's video, where we'll be looking at a Kaggle dataset, specifically the Spaceship Titanic dataset, and we'll be doing some basic exploratory data analysis and machine learning prediction on it. Hopefully this will be helpful to whoever's watching to get started on their journey. So the Spaceship Titanic dataset is a dataset that's from Kaggle, and it's a competition when anyone can join. And basically, it's a very simple classification problem whereby you just need to evaluate whether the passenger ID is transported with a Boolean with a true or false. Okay, so if you want to find out more information, you can just check out the link in the description. And I will also be using Google Colab in order to code this, but it should work for any IDs as well. And similarly, I will be sharing the link of my notebook in the description as well, along with the Kaggle competition page. So let's get started. Alright, so the first thing we need to do is that we have to download the Kaggle dataset. So there are a couple of ways, 2 ways you can do it actually. One is to utilize the Kaggle API in order to download the data directly into it. The alternative is to download the files manually from Kaggle and then upload it. So of course it's easier to use the Kaggle API instead, and so that will be what we'll be using in the notebook. Okay, so important thing is to take note is you have to supply your own secret keys. Okay, you have to use the Kaggle key and the username as well. So each account sign up with Kaggle will provide you with its own specific token, which you have to put it here in order to use this. And then over here we will be downloading the Spaceship Titanic dataset. Okay. The next step will be to import the libraries which we will be using. So these are a couple of libraries which we will be using. Pandas, of course, to set up a data frame, and then Seaborn and Matplotlib is mainly for plotting. Then the rest are standard scaler and label encoder from the scikitlearn, and these are for pre-processing the data. And then the rest are just the common various machine learning algorithms which we'll be using from scikitlearn. And apart from scikitlearn, we will be installing Tensorflow random forest as well. So we'll be testing them out to see how's their efficiency in terms of predicting the variable. Okay, so because there's quite a lot of libraries to download, so this will probably, if you run this will probably take a couple of minutes to run. Okay, the next thing is we have to take a quick look at the metadata from the file. So you can find all of this information from the Kaggle competition page. So I will not be going in depth into it. So if you want to, you can just pause and then just read through the screen. So basically these are the different columns that I have available within the file. Okay, and each of them kind of mean different things, and we will be taking a deeper look into each of this later on. So we can begin our exploratory data analysis. So just one thing to note, what we'll be covering today will be very simple exploratory data analysis, and it is actually as much of an art as it is science. So I don't think that there's a prescribed perfect way of actually approaching this, and it's actually up to each individual how they would want to look at the data, explore it, and to slice it and pre-process it. Okay, because different ways of pre-processing, you with along with using different types of models, will give you different results. Okay, so let's get started on the exploratory data analysis. So the first thing that I will want to look at is to check if there are any missing values in the data set. Because if the data is unclean, then we would have to change it accordingly, such as so that the data can be used. So from here, we can see that actually most of the columns have null values, have missing values. So we would have to populate them with a value of our choice, right? So the next thing is we can look at some of the rows with missing values. So we can see that for this row here, we have a NaN value for the VR deck, and then the next one we have a NaN value for shopping mall. Okay. So now where we can another thing that we can look at is also to look at the data type, so that we will know what needs to be populated or changed. And same thing as well, because we might need to change this data type such that it's in a format that can be fed into the machine learning algorithm as well. Okay, so the first thing that I would like to do is to actually try to split the column cabin into three separate columns, which is the deck, the number, and the site. So if we are to look back at what this cabin means, right, from the metadata here, it's actually showing the cabin number where the passenger is staying, and that's the form of the deck, the number, and the site which could be port or starboard, right? So because there are three separate perhaps valuable information that is stored within this column, and that's why I thought that perhaps splitting it might be better, and it might help to improve the model performance as well. Okay, so after splitting, we can check, we can see what are different types of values that we have for the deck, and we can see that there's a now NaN value as well. So in this case, I'll be choosing to populate it with the replace all the null values with deck F, which has the highest number. So this will help to actually kind of centralize the number of it, so that it doesn't change the distribution of it too much. And so we will do the same thing for the deck and the number as well. So in addition to what we're doing on deck, I will be applying the label encoder to it, so that all of these values can be stored in a single column instead of having it in multiple columns when we do for a one hot encoding. So this is to help to reduce the number of variables as much as possible. Okay, and then we will also be so same thing for the column number. We will be filling the null values with the highest with a different unique value instead. Okay, because we can see that the distribution is pretty sparse. Okay, and that they are spread across many different types of numbers. So thought that defining a single number would be better. And then likewise we'll do for the site as well. Okay, because clearly you can see that it's pretty even here. Okay, so next thing, we can take a look at the distribution of the transported people staying at different cabin numbers, and we can see that it's pretty even. So for this case, this will be the only chart which I will be doing here, but it is entirely up to you. If you some people are more comfortable looking at charts visually in order to extract data. So unfortunately, this will be the only chart that will be displaying in this notebook, and perhaps we could explore more charts in future datasets. Okay. Next, we'll move on to the next column, which is the home planet. So similarly, we'll be looking at the three different things like the number of unique values in it, and then what are the values, and also the value counts. Okay, so we can see it all here, and then for this, we will be applying the one-hot encoding instead. So the reason why there's no changing of values or so is because that this will actually be dropped. Okay, and then because we have put the drop first, which means to say that it will ignore the one with the highest value, and since that's the case, let's assume that all those null values will be defaulted to Earth as well, and that's why it was not filled over here. Okay, and we will do the same thing for the destination as well. Then we'll fill up the any values of the remaining columns with an appropriate value. Okay, so it'll be for cryosleep, will be false. Okay, then for the age, I will fill it with the mean because we can't really define it as 0 or even the highest number, because that would probably not make sense. And so that's why I've chosen to default it to the mean value instead. Okay, and then for the amenity list, I'll default all the values to 0. Okay, so the reason why I default the values to 0 for this 5 columns is because if we scroll back up to take a look at the metadata, okay, where is it? These are actually the amount of money that they have paid for, right, at each of these luxurious amenities. So if it's a null value, we can just take it as 0 for those columns. Okay, so we will do a check again to see if there are any missing values, and we can see that there is for Kevin and for name, but it's okay, it's fine, because we can ignore them later, we can leave them out later. Also, okay, so next we can look at the distribution, okay, of the numerical columns as well. We can use the describe function in order to take a look at it. Then another thing that we need to take note of is the dependent variable. So it will be good if there's an even mix of it, because if it's uneven or if it's skewed to one of the Boolean value, then we would have a problem, as the data set will be skewed, and then the model won't be able to predict as accurately as possible. So it's always best to have an even mix of it. So looking at the number count, it's an even mix, so it's fine. I don't think we need to do any further processing for it. Okay. Apart from that, we can take a look at the correlation between the various independent variables. So in this case, it will go from a range of -1 to 1, and if it's 1, it means that there's a very high correlation. So in this sense, if we can see this home planet Europa is a value of 1, and over here we can see that it is the same. So of course it will be highly correlated with itself, but if we take a quick glance, we can see that there isn't any one variable which is highly positively correlated with another variable, nor are there any variables which are highly negatively correlated. So in this case, this is good as well, because it means that the variables are independent as much as possible. Alright, so next we'll move on to training the machine learning algorithms. Okay, so first off, we will drop off the columns which are not needed. So in this case, I'll be dropping off the the dependent variable, and then we can ignore this two as well, because I don't think that they will make a difference, especially since we have already split the cabin into 3 separate columns. Next, we will scale the data as well. Right, so this standard scaling will help to normalize and transform the data such as it's within the same range, and this will help with the performance of the machine learning algorithm as well. Then we also define the y-train, which is the target variable, the dependent variable which we want to predict. Then we'll do the usual splitting of data between the training and validation set. Okay, and then I will be feeding in this list of models, and it will iterate over each of these models. Okay, and then it will score it. So I will record the training score and the validation score into a pandas data frame as well. So you see all these models here. These are the various scikit-learn models which we can try to use to test and see which one has the best performance. So because I have not specified any parameters in any one of them, so it will just take the default values for each of the parameters in each of these models. Okay. So apart from the scikit-learn machine learning models, we can also do the same thing with the TensorFlow decision tree models as well. Okay, so over here, we will do the same thing here. It's just that we will be changing the data type to integer, and also transforming the data frames, pandas data frames, into a TensorFlow dataset, which is for the TensorFlow model to ingest the data as well. So same thing as well. We will have we'll throw in a list of the various TensorFlow models, and then we will iterate over each of them, and then train it, and then also save the accuracy of the models as well. So once that is done, we can take a look at the data frame which I have stored all the models, and we can see it over here, right? And looking at this, what we want ideally is to have the validation score and the training score as close as possible. And we can see that we can see the performance of each of the models here. The one that is probably the best or the closest is not necessarily the one with the highest train score, but the one with the closest training and the validation score. And so in this case, this would probably be either the AdaBoost classifier, or we can try with the gradient boosting classifier as well. Okay, so either one of these two would be good, as both of them have the closest score, and they also give the highest validation score as well. Okay, so now after that, we'll be going into the submission of the file. So we can take a look at the sample submission file. You can see that it's just made up of two columns, a passenger ID and the predicted column, which is either true or false over here, right? And then so next step is actually basically rinsing and repeating whatever we have gone through above. We will be pre-processing the data first before we feed the data into the model for prediction. Okay, and over here we will generate the submission file. So I have prepared two different sets of cells over here. One is for producing the submission file from the scikit-learn model, and the one below here is producing a submission file based on the TensorFlow model. So actually it's nothing much. It's just predicting them, fitting the data to the model, predicting, and then storing the data in a data frame and saving it to a CSV file format. And likewise, that's the same with the TensorFlow model as well. And so that's the end of my notebook. So there are a few additional considerations which are not covered in the notebook. And some of them are things such as data pipelining, where previously in the notebook we see that we have written multiple lines in order to transform the data. But for data pipelining in scikit-learn, we can add all of them into a single line, and then whenever we run this line of code, the data will always transform as per the specifications. Next, we have grid search CV, which is also only applicable to scikit-learn, where it actually helps to perform an exhaustive search over specified parameter values for an ideal estimator. Because in the notebook, we have not specified any parameters, and they are just taking the default values for each of the machine learning algorithms. Next, of course, we can use a neural network to try and predict the labels of transported, which we have not done in the notebook as well. And that's the end of the video. So some of the topics, just a quick summary of the topics that we have covered. We have looked at how to access and load the Kaggle dataset into the Google Colab. Then we have also done some basic exploratory data analysis. Then we have also done data pre-processing for machine learning. And lastly, we've also covered the training of the various machine learning algorithms from the scikitlearn library. So thanks for watching, and do you have any thoughts on the video? Feel free to comment in the comment box down below. And if you like this video and would like to see more of such content in future, please be sure to like and subscribe as well. Thanks for watching, and until next time.